For this next part of probability, we're going to go into the fundamental counting principle. And this is a quicker way to determine how many possible choices we have without using a tree diagram. So if we look at this part right here, if there are m ways that one event can occur and n ways that another event can occur, then there are m times n ways that both events can occur. So we can use this, m times n times p times q and so on and so forth with as many options as we have. So in this first example, we have at a cupcake shop, you have 8 different choices of cupcakes, 6 different frosting choices, and 4 different sprinkle choices. How many total different combinations can you make? So using the fundamental counting principle, we have 8 different choices of cupcakes times 6 different frosting choices times 4 different sprinkles. Now you can imagine how long this would take to do a tree diagram. It would take quite some time. So we just plug this in our calculator and we get 192 possible combinations. So for this next one, we have Martha, who is choosing a password for her email account. Now she decides not to use the letter M or the digit 7 for some odd reason, and each letter or number may be used more than once. So we can repeat letters. We can use as many A's as we want, as many B's as we want, and so on. How many passwords of 3 letters followed by 4 digits are possible? Now this is how I like to set these up. So first off, we want 3 letters. So I have 3 banks for letters. And then 4 digits. So then we have 4 little banks for our digits. Now, how many choices for letters do we have? Well, normally we'd have 26, but we can't use the letter M. So we're only going to have 25. Now we can repeat them. We can use them more than once, so I still have 25 letters to choose from and 25 letters to choose from. If I'm not allowed to repeat them, they'd go down by 1, 25, 24, 23, and so on. Now, for the numbers, for the digits, we have normally 10 digits, 0 through 9. Well, I can't use the digit 7, so I have 9 digits. And remember, we can use numbers and letters more than once. So we have 9, 9, and 9. And we're just going to multiply all these numbers together. So once we do all that math, we got 102,515,625 possible combinations. So it's going to be quite difficult for somebody to hack into Martha's account.